Solve the inequality and then graph the solution set. We have 4 divided by x minus 2, which is greater than or equal to 2. So the first thing we want to do before we find the interval boundaries is that we need to make sure that we have a 0 on the right side of this inequality. So we're going to subtract 2 to the left side of the inequality. So we'll end up with 4 over x minus 2. Subtracting 2, we have minus 2, and which is greater than or equal to now 0. So this is the same thing as 2 over 1. On step number 3, we want to find the common denominator between 1 and x minus 2. Well, the common denominator between 1 and x minus 2 is x minus 2. So what do we need to multiply by 1 to get x minus 2? Well, that's x minus 2. And so we got to do the same thing to the numerator, so that becomes 2 times x minus 2. On the left side here, x minus 2 times 1 gives you that x minus 2, and then 4 times 1 is 4. Now, in step number 4, we have 4 minus 2 times x minus 2 over x minus 2, and that's greater than or equal to 0. And now we're going to distribute that negative 2 to both of those terms and then combine like terms. So we have 4 minus 2x plus 4 over x minus 2, and that's greater than or equal to 0. So now we end up with 4 plus 4, which is 8 minus 2x over x minus 2, which is greater than or equal to 0. Okay, so what we can do is we can, if we wanted to simplify this a little further, this would be the same thing as factoring out the 2 in the numerator, and what we'd have is 4 minus x divided by x minus 2, which is greater than or equal to 0, because this means the same thing as this numerator. It's just in a simplified form. Okay, now in order to find the interval boundaries, in the numerator we have 2 times 4 minus x divided by the denominator, which is x minus 2, and then we're setting that equal to 0. In the numerator, we have a variable, so we need to solve for x in the numerator. So this is 2 times 4 minus x, which is equal to 0. We first divide both sides by 2. So we have 4 minus x, which is equal to 0. Subtract 4 to both sides. We get negative x, which is equal to negative 4. Divide both sides by negative 1. And then that boundary is x, which is equal to positive 4. Step number 3, we're going to take x minus 2, which is in the denominator, and solve for x. So x is going to equal to 2, and remember that this is a restricted value, which means that because it makes the denominator 0, if we let x equal 2, it would make it undefined. Okay, so now what we're going to do is draw our number line that includes those interval boundaries. So there's our number line with our interval boundaries going from negative infinity to positive infinity. We know that the one interval boundary is 2, and the other interval boundary is 4. So that's going to give us 3 intervals. Interval 1, interval 2, and then interval 3. The first interval goes from negative infinity to positive 2. The second interval goes from 2 to 4. And the third interval goes from 4 to positive infinity. So now we can use step number 7, which is 2 times 4 minus x divided by x minus 2 as our testing interval. So for interval number 1, we're going to pick the easy value, which is x is equal to 0, and then plug that in. So this is 2 times 4 minus 0 over 0 minus 2. So this is 2 times 4 minus 0. Well, that's 2 times 4, which is 8. 0 minus 2 is negative 2. 8 divided by negative 2 is negative 4. And so is negative 4 greater than or equal to 0? Well, the answer is false. So it's false for region number 1. For region number 2, we can pick a number in between 2 and 4, which we can pick 3. We're going to let x equal 3. So this is going to be 2 times 4 minus 3 over 3 minus 2 to see if that's greater than or equal to 0. Well, 4 minus 3 is 1, and 1 times 2 is 2. 3 minus 2 is 1. So 2 divided by 1 gives us 2. And is that greater than or equal to 0? Well, the answer is true. So we know it's true for interval 2. For interval number 3, we can pick x to be 5. So we're going to plug it in. So it's 2 times 4 minus 5 over 5 minus 2. We want to see if that's greater than or equal to 0. 4 minus 5 is negative 1. 2 times negative 1 is negative 2. 5 minus 2 is 3. So this is negative 2/3. So is negative 2/3 greater than 0? The answer is false. So it's false for region 3. So the only place that we have it's true is interval 2 going from 2 to 4, and that's where it is true. But again, before we answer our question, we need to look at the inequality, which is less than or equal to. And so we know that 2 is a restriction, so we have to keep the parenthesis at 2. But 4 is not a restriction, so we have to put a bracket there. And therefore, there is our answer. So it goes from 2 to 4 with a bracket. Let's go ahead and check our result. We have parenthesis 2, comma 4 with a bracket. Check our answer, and there is our result. Now it says graph the solution set. Well, we did, right? So if you take a look here, here's the graph. There is the parenthesis at 2, and it's going to 4, which has a bracket. So we just need to find which graph matches that. So it looks like the 2 has a parenthesis here and has a bracket at 4, so it's going to be D. Let's check our answer, and there is our result.